Okay, welcome to our April 6, 2019 structural modeling video conference. Today we're going to go over two basic items and kind of detail between these two and how they interact. The first thing we're going to go over is the augmented model exchange isomorphism, the second version 2.0. And we'll kind of give some pointers to the things that were changed and the new scope variable. One of the major additions to the version 2.0 was we added a new scope variable. Then we'll go over the augmented interactive management software and spend some time talking about the development of the application, development process, and then talk a little bit about features, what people would like to see first, what makes sense to do first, talk a little bit about next steps, then also talking a little bit about requirements and test teams. So we'll talk a little bit about some of the general ideas of putting together the requirements for this particular application, but also some of the testing frameworks, and then also solicit people that would be interested in providing requirements, prioritization input, and also testing the application as it's developed. And then we'll spend some time summary and wrap up and kind of connect these two specific major points here, the augmented model exchange isomorphism 2.0, how that's going to impact the augmented interactive management software, and then how that will impact our next document, which we're going to have ready for the May session, which is going to be applied natural language relationships. So we'll put that together and start talking about that and walking through it. So I'm going to transition now over to the version 2.0 of the augmented model exchange isomorphism. So what we've done in the augmented model exchange isomorphism is we've added a series of pros, names, and from a natural language standpoint, we call them relationships. From a logical standpoint, we call them predicates and statements. But what we've done is we've categorized these natural language prose statements in terms of their logical properties. And so these are the basic three logical property groups that we've used: reflectivity, symmetry, and transitivity. Version 2.0, all of the properties and subproperties are the same. However, they have been moved a little bit on the cube faces. So they've been rearranged slightly, but they're all still the same. All right, so then the idea here is that we have natural language relationships or predicates that essentially are assigned to one of these groups: reflectivity, symmetry, and transitivity. And most of the books on predicate logic, first order predicate logic, second order predicate logic, or type theory, they don't bring all three of these particular concepts together. They, for example, talk about reflexive here, and it's identical with or divisible by, but they really don't say, well, identical with has a reflexive property, but is it symmetric and is it transitive? So that what we've done is put these together and created these groups, 27 groups that we can basically put associate the natural language relationships with logical predicates with. And in doing that, we eliminate the uncertainty of, well, are other logical properties controlling? What other logical properties are involved here?
Joe?
So here, yes.
Have you seen a treatment of first-order logic which allows anything but a transitive property rather than the other two for that one?
Well, that's a good question, Kevin. So in zero order propositional logic, basically the logic and is based on the form of the argument. In first order predicate logic, the logic is kind of based on the I'd say the quantifiers of the subject for all, every, you have these quantifications, first order predicate logic. So when you get up into second order predicate logic and type theory, and you come to a point where the logic of the statement is based on the relationship. So if we say something like a city is north of, right? And then A is north of B, B is north of C, therefore A is north of C. That depends upon the logic of the natural language relationship of the predicate, and that's second order predicate logic, right? So it doesn't quite fit into the ideas associated with first order, and so that's one of the issues, because we're not, in this case, we're not really talking about any specific predicate or word like north of, precedes, bigger than, smaller than. All of those predicates will fit into a logical group, which is kind of a type. So we're kind of balancing between second order predicate and type theory. Did that answer your question?
Also, I haven't looked into this, but I know from the people I follow talking about type theory and functional programming and the uses of category theory on Twitter, there are many logics that are opened up in when you take a categorical view. Maybe I'll look for I think John Baez has a nice chart showing the relationships. So I think, if I'm addressing your question, Kevin, I think there are all of these cases of intransitive, non-transitive, everything that Joe and Mary are addressing are opened up for study in current categorical approaches.
Yeah, Janet, that's my understanding. It's like, for example, if you just take a specific predicate, not a general class of predicates, you take a specific predicate like is taller than, right? Then you can create an is taller than logic. A logic that's just associated with that predicate. So what we've done is we're not focusing on a specific predicate at this time. What we're doing is we're talking about these different groups, these different logical property groups. So we're going to expand on that as we go forward. And to specifically answer Kevin's question is, I really haven't seen one that's just only associated with transitivity, because in my understanding, you really need to have some type of symmetric relationship for the transitivity to ride over. I mean, something can't be transitive and not symmetric, or or non-symmetric or asymmetric. It has to be, if it's going to be transitive, it also has to have some symmetry, right? Doesn't necessarily have to have reflectivity. Well, but that's what irreflexive is about. So anyway, that's kind of where we're going here, though. That's the idea. Is we're going to now, we've kind of done this for completeness, done all these categories, done this for completeness. Then we're going to start talking about the logical properties, and then, as I said, we added the scope property, and we'll talk about that a little bit. Then we'll talk about how that changes the question that you need to ask. Because really what we're using is logical operations to guide the empirical selection to reduce the cost. So that's what we're doing here. So the original...
Joe, can I ask another question?
Oh, sure.
So the three values there of pro, con, and neutral.
Right.
Maybe it's helpful to associate those with modalities of necessary, possible, and impossible. I had trouble when I first saw you doing this, just grasping what the non-category would be if you're not. I guess in next month you will be analyzing the natural language relationships to see which are meaningful, and there maybe my confusion will be more addressed. But but it seems like when you're dealing with relationships that are empirically derived rather than logically defined, if whether or not there are connections depends on what the group determines. Is that correct? But I guess that's on the one hand, it depends on what the group says. On the other hand, it depends on, you want to be able to call on a toolbox of constraints and make specify necessary, possible, impossible, whether they recognize it or not. I don't know if I'm trying to state several things simultaneously. I guess part of it is natural language relationships. Part of it is predicate constraints, and then the mathematical relations. I like that distinction. Anyway, I don't know if I'm saying anything that can be responded to, but these are things that I've pondered since I started watching you do this.
Well, Janet, those are all really very interesting questions. And so first of all, the application, when you're in front of a group of people, or you're bringing people together, you're preparing a group, what I proposed in the past and what I'll detail in the next one is you really can use questions, right? For reflectivity, you'll say, well, is A, right? Is A the same as A, or is A bigger than A, right? So you can ask the question to the group, and you can associate those answers, right, to reflectivity. It's either reflexive, right? Is A the same as A? Yeah, that's reflexive. Okay, good. And they say, well, is A bigger than A? No, that's irreflexive, right?
Mm-hmm. I guess what I'm picturing is that, and I don't know if this happens in practice, is that since you're sort of simultaneously defining the objects and the relationships in this process. So I was picturing that there might be cases where people would say, oh yes, A is, has this relationship to itself. But then when they are looking at another object, they might say, no, it doesn't. And so is that because their objects are not defined coherently, or because the relationship is not, or does that come out in the wash later, that that you will say, if A is
Well, no, what we do is we allow that. That's non-reflexive. It's both. Non-reflexive, it's as though I have objects that can be like irreflexive and reflexive. So say you have a group of people and you have the relationship loves, right? Some people love themselves, other people don't love themselves, right? And so you have a group of people, right? And so given those conditions, that would be non-reflexive because you have some people that love themselves and you have other people that don't love themselves. Therefore, you have objects that are both, right? And because we're talking about a system, we need at least two objects for a system. Therefore, both objects can be irreflexive, both objects can be reflexive, or one object can be irreflexive and the other object can be reflexive, and that puts it into the non-reflexive category.
Right. But I still have a feeling similar to the question about transitivity, maybe, that the non-cases, once you get going with this kind of analysis, maybe would be refined by saying, oh, the reason we have some of them yes and some of them no is because we need to redefine what our objects are, or we need to redefine what our relationships are.
Oh, okay, I see. Okay,
yeah. I can see that in practice, as people are stepping through the questions and the pairwise comparisons, that you might get inconsistency of definition. And I've the way I told you a long time ago that my mother used to do this kind of thing for my father in helping develop factor hierarchies. And then the question would be, is that a flag of something that should be further, excuse me, further clarified, or do you tolerate, that kind of, and again, I guess this comes down to the natural language relationship. Sometimes it would be meaningful and perfectly okay to have the mixed relationships, but as you're moving toward a more mathematical model, I wonder if those should always be a flag to reconsider what your objects and your relationships are.
Yeah, that's very insightful, and it's kind of further down the line. And so the idea here, and what I hear you talking about, is a difference between what is allowed by valid logic and what can be encoded into the binary matrix. Because all of the 27 groups, logical groups, they can be encoded into and can be represented by a binary matrix, which is a proposition, either true or false, each one of those things, right? But many of those are, those groups don't create, let's say, logical issues. They can, if certain conditions are met, then there really wouldn't be considered valid logic in, let's say, first order predicate logic, or maybe second order. But in type theory, you're making your own rules, right? So that's kind of the transition level we are working with here.
Right.
And so bringing the group in, and what value, how can we effectively use the logic to reduce the cost and the resources? And then how can we use that for group learning, to reinforce group learning within the group? Those are all really important things. So,
and Michael just asked a question in the background. There's also a question of the inseparability of objects, where it might turn out that, again, I picture this as something that would come up in practice, that that there are two different, that it turns out that you either have two different ways of phrasing something that turns out to be one object, or vice versa. that you name something that is really two objects, and maybe from one point of view it has certain properties in relation with others, and from another point of view it doesn't. So I guess again it comes down to what you were just saying about different criteria for the empirical natural language modeling, the logical modeling, the binary matrix. They all have different criteria that need to be mapped to one another, something like that.
Well, it's very interesting, the idea of identity and, you know, what the object is and what you're talking about and what is specific about the group, especially a large distributed group. I think the most, maybe the easiest example to understand there is like budget. And we used to have this concept of technical budget, so we'd assign that over completely over our program, right? And that's a program for the whole system. So the whole system itself has X amount of technical budget and has technical margin and reserve, right? Mm-hmm. And then you go down through the subsystems and all the way down. Well, the guys down at the lower level, right, of the subsystem, they would take all of the margin for the complete system for themselves and ignore everybody else, right? Because that for the system, they were thinking, oh, this is my system, right? And so it depends on the scope. It depends upon how you put it together, but that is a integrative learning group process. And what we found was basically you had to do that. You had to bring people together into a room, and you had to normalize the language. You had to normalize all of these very specific things, right? Mm-hmm. Because if you didn't, they were only thinking, you know, in terms of what they were talking about, what was important to them. So yeah, these are all very important things, and it's things that I'd like to see, like the psychologists and the group interaction people, organizational dynamics people, you know, deal with, because this is where this is going, right? Supporting
right. I guess there's also, and I can't think of the word at the moment, but there's the question of whether the objects have any identities apart from the aggregation of all of their relationships. So,
yes,
you know, right. Do the objects come from the relationships, or the relationships come from the objects?
Yeah, and so the way we get around that, the way Warfield got around it, was the levels of definition, right? And so added the definition by relationship. And so it's how well you're defining. So there's this ladder of definition. John Aubrey is going through that with now just looking at two, right? Two levels of definition. Whether you give a set of rules, right? And say, oh, anything that meets this rule set, intention, or if you list everything, right? You list everything, you said, oh, well, all these things, then that defines what this term is. But the other one is definition by relationship. And what you can do with definition by relationship is you can actually relate those two other types of definitions together. But we'll get to that. That's kind of what
also what Peirce's firstness, secondness, and thirdness is about. Charles Sanders Peirce's thing, I think Warfield referenced him talking about this type of thing, but he didn't go into it too much. Anyway.
Yeah, well, yeah, so mostly we're in rules now, so we're most rules and definitions, so we're up in thirdness right now. So it's yeah, but we're just taking this a step at a time and documenting it and trying to get footholds in these areas. So those are all good questions, though, and good comments and good insights. Actually, I think this can really benefit the complexity issues, because we're reducing uncertainty by addressing these. See, if we hadn't done all 27 groups, then we wouldn't be pointing out these inconsistencies between the different types of logic. Okay, so now for the scope variable. So what we did is in 2015, we did the organizing properties of symmetry. And so we have the hierarchy, asymmetric. Then the non-symmetric, you can see here, is basically it has asymmetric and symmetric together, so it's non-symmetric. And then, of course, network is a symmetric. And what we found in going through our work was that in this hierarchy, we say the top, the top bubble is higher than this lower bubble, and then it's also higher than this lower bubble here, these two, right? But these two bubbles are not related to each other, right? So there's no global connection. It's not this particular format. This is not a global relationship. It's local because we have things that are not related to each other, not there. We added this scope. We added the scope parameter in 2017. Added this. We have a single thread. Now this is heavier than in like a global weight field, right? In a global gravity field, everything is able to be related to each other by weight. There's nothing that you can't compare by weight in a global gravity field. So that's single threaded. And then we have similar ideas like taller than, left of, north of, things like that. Those are conceptual ideas of, that we map over space, but it applies globally, right? So that you can relate everything by height. You can relate everything by positions on a map. It's global. So that's our global, single-threaded, asymmetric. Now the multi-threaded, as I said, this is local, okay? So what happens here operationally is in the single-threaded piece logically, you can say, oh, is, it's 1 higher than 2? Is 2 higher than 3? Things like that. So you're comparing objects. In the multi-threaded, you have to ask what is higher than. So you start at the bottom and say, well, what is higher than this one? What is higher than this one? And so in both cases, the empirical knowledge is in the group, but the single-threaded one, you can compare 2 objects logically and get a reproducible answer. Multi-threaded, you just have to depend upon the knowledge of the group. And so you have to ask the group and keep track of that. So it's a different type of software application. It doesn't use a logical inference. It just keeps track and makes sure that you've done the bookkeeping and asked the empirical information on everything. So again, on the combined hierarchy and network, we have the single-threaded, multi-threaded, and of course symmetric in the network. There's no concept of single-threaded in the network piece. We'll point out in some of the techniques. Now the condensation that Warfield came up with to condense these networks into a single node then makes this non-symmetric into back to a asymmetric approach. So this is a practical, operational thing that you can do to leverage the logic that's associated and the efficiency that's associated with the logical operations in the first two, and then basically we can go through and we'll detail some other ones. But now we're starting to outline. So if you have 27 logical groups that can be of a global class, and we have 27 logical groups that can be of a local class, and you really have 54 different types here. And so the idea now is to start looking at these types and grouping these types and see which ones are important. And I think this goes along the lines of what Janet was saying about, well, what about the objects? What about overlap? You know, do these things really matter when you're using natural language? And what you need to pay attention to when you go from natural language moving, which is informal language, moving more and more formally toward mathematics, which is formal language. So that's the addition there. Okay, so let's...
Joe, just one
Sure.
note on the condensation.
Yeah.
So an issue we have with Warfield's approach to condensation is in the matrix. So, the condensation happens, when you have a bunch of ones filling the matrix, either, typically in a cycle is what he condenses, right?
Right.
It appears as a cycle, and then he condenses it to a single node.
Yep.
Right. And then he continues the inquiry, adding more nodes through pairwise questions to see where they fall in the structure, right?
Right.
But if you ask about just one node, typically what Warfield does, or at least in current versions of his software, they just pick the lowest or highest number node that's in that cycle, the thing that's been condensed, and they keep pinging the questions on that one node, not all the other nodes. So
yes,
it biases the whole, everything that is in the condensation gets treated as one node. Mathematically, that makes sense, but when each node is a different statement and you keep pinging the same single statement, and when there's 5 in the condensation, it creates a bias. So it's something that, when we're looking at the new versions of software, we don't want to fall into that trap. You should at least randomize which question you're going to ask, if not show all 5 that you're asking about.
Exactly. That's really a good point, Kevin. And that's, again, why we're going over this and talking about these things. And then that's a requirement for the software you just stated.
Yeah.
So that's exactly correct. And that's what this is all about. And we'll be visiting that again as we continue to refine the software requirement. And there's different things you can do. We've developed some other structural evaluations, but what we're proposing is a more robust type of software set of functions that allow you maybe to even concurrently look at the output of 2 or 3 different threads of analysis. So, but that's later on, and these are the basics that we're kind of going through now, establishing the types and how they would support the group interaction. So another thing that happened with the 2.0 is that the colors were taken out. So the colors now don't have a semantic meaning. So it can be printed in black and white and not lose the semantics of the document. And also some of the rearrangement of these particular logical components in the chart were just removed 1 or 2 sections. So you can see here there's no color now in this. It's reflexive is dash, symmetric is reflexive is a small dash or a dot, reflexive, and then symmetric is dash, and transitive is light gray solid. So, and it shows you what these are. And then of course we have the matrix, that's the binary matrix, 0, 1, either true or false, if they're connected or not, right? And this relation, of course, is connected to. The other thing that we're looking at here is the idea that does a natural language relationship or a predicate fit only in 1 bucket, 2 buckets, all 27, how dispersed is this concept? So now that we've developed these groups and have are looking at these specific attributes, then we can use these as metrics to say, okay, this type of natural language relationship is better than, is more focused and gives us, you know, more detailed information than a different type. So we hope to develop those types of metrics as we go forward. I won't go through these all, but anyway, now they've been changed so that they can be reproduced in black and white and still have the same information. And so I think I will now go ahead and move on over to a little bit of a discussion of the AIM project and where we are. So I don't know if everyone can see that screen, augmented interactive management. This is the landing page that Mary created for us, and kind of gives the steps in the process as we go forward. This basically is a JavaScript full stack server running on my laptop here. So you go through, and this is, as I said, it's a landing page. And then we'll go through here, and it kind of details, kind of gives a brief introduction to the processes and what they are. Then below it just has some very brief statements about what each specific step is. Then these links will take you to their own space. And so these pages will have written instructions, and then they will also allow you to pick, you know, what you want to do. Do you want to do a idea generation, pencil and paper in a room with a bunch of people? Do you want to do it with a dispersed group? You want to have it mixed? How do you want to do that? And essentially, hope it will allow you to pick those operations. If you decide to do it in a room with pencil and paper and just physical paper, then it'll have instructions how to do that, what's important. You want to do a dispersed thing that's networked and computerized, they'll have a plenty of software and so forth. So we were going forward with that, and then of course interpret, clarify ideas, and we're going to go through and just basically update, fill all these in. So we'll have again have the processes, and then have a sign in and a join here. Those are not active yet, but the program will have the ability to sign people in, and track who they are, what their roles are, role-based type of authentication and so forth. And so we've just gone through, and I've just set this up. I haven't filled in much more than that. This particular set of software is not on the it's not out on GitLab yet. I'm working at just a little bit more to see, make sure that I'm comfortable with the framework, and then I'll kind of go forward with that. But what we plan on doing, as far as prioritizing, is starting more in the structure ideas area, because that's what we've been working on here with the logic and logical groups, and structuring the ideas. The generating ideas, clarifying ideas, and amending ideas, those don't really seem to have the type of logical structural interaction as the structuring the ideas step does. And these are more like administrative bookkeeping things here. And it's either done physically, managed in a co-located room, or managed using computer resources in a co-located room, or it's distributed and co-located. You know, those are the types of operations we'd want to support in these specific steps. But we're going to work on the structure of the ideas piece first. And then we interpret the ideas, amend the ideas, and select preferred ideas. We're going to have similar types of computer functions and operations to the first three. We'll just be focused on different subject matter. So we believe that when we do these first three, then it will give us the basis for the last three. And kind of the structuring ideas is kind of the kingpin, linchpin in the whole operation. So that's kind of what we want to do there. We're at 45 minutes now. So we did the augmented model exchange, we've done the interactive management, current state of development. We just talked about the future development priority. I'm going to focus on the structure ideas, and then do generate, clarify, and amend ideas. But we need to also kind of work on those, and anyone that has ideas or requirements for how those should be done, be glad to get those documented and get those moving forward. The GitLab itself is a software development process. It's hosted online. Because we're doing an open source application, then all of the support that's provided by GitLab is free for open source projects. And it has a very well-defined standard feature request, issue logs, all those kinds of operations where you can just, anyone can go in there, I believe, yes, anyone can go in there and make notes and give feature requests. And I know that's probably not in the experience patterns that you folks have. So if you have any feature requests, or if you have anything that you would like the software to do, be sure and email me and let me know. And then I'll put it into the GitLab. And then as that builds up over a period of time, I'll demonstrate it so people will get an idea. It's fairly easy to do, and pretty straightforward once you've, get a few basic concepts and ideas down. So with that, let's see, are there any questions? Comments? All right. Well,
so this page that we're looking at right now, is this the front page of the software, or it's for a deck, a presentation deck?
No, what we're looking right now is a live, this is a live server. This is live software running right now.
And it's and the package you've written is in GitLab, or it's hosted by GitLab?
So GitLab is, well, let me just go ahead and bring this up a little bit, see if I can get over here to GitLab. Oh, here we go. And I'll bring it up. Okay. I'm going to switch over now to the AIM project on GitLab. So we'll get this presentation away here. We'll stop this one. And we'll go over here and we'll bring up the, let's try this. I think this is it. Right, this is it. Okay. So this is GitLab. And what we have here is it's https gitlab.com JJS0SBWAIM. This AIM project. I'll put the link out in the notes when I send it out. But so we have project ID. It talks about you know, the license, the README, and so forth. But right now on the AIM, right, in this GitLab, there is let's see if I can make this a little bigger. There's no real code, right? So what it does is it kind of outlines the purpose of the project, but it says read the wiki, right? So the wiki is over here, right over here. Right now, the wiki is what has the development background in it, right? And so I've basically put together where the main documents are, a research gate, and put some supporting documents for the software design on ResearchGate here. And then go over here, go to objectives. Okay, you know, our software objectives, what we're doing, what we're going to work on first, right? And the document, the system structure, the DSS, that's where we're just keeping track of things. That's what I've kind of put in as a grab bag for all the other functions will be kind of in that class. And then libraries. Okay, so then here I'm starting to describe the libraries I'm going to write in JavaScript, right? So this is kind of the description of those, what they're going to do, and so forth. But this is all text, as you'll notice. So we go back over to the repository, right? There is a license, which is a general public license, version 3.0, so it's open source, right? Files, there are in a README. I have put no code in here yet, right? So the code that we were looking at before, and I'll go back, I'll stop sharing here, back and look at this code here. So the code to run this application is not in GitLab yet. And so I'm working this. The framework I'm using is Vue.js and Node, which is
Vue.js and Node.
Yeah, Vue.js and Node.js, right? And they're maturing very quickly. So when I started writing this program, Vue.js was just exploding in functionality and popularity. And it had many different ways to put it, you know, to use the packages that were provided. And that became an issue. So the guy that wrote Vue.js sat down and wrote a new set of functions that basically manage the complete full stack development project now, right? So I'm in the process of changing over to that new tool set. And when I get that tool set in there and I get it tested, then I'll move it up. Hopefully I'll have the first set of code in by May 1st. So, around the 1st of May.
Okay.
So that's kind of clear. There's kind of two different things. One's the GitLab open source place that doesn't have the code in it, and then this code is running on my computer right now. But it will be.
And you had done a couple previous implementations in other packages, right?
Yes. So what I've done is so Right. So I did I did just pure JavaScript, handcrafted everything for the applications before that. Um, they were, they're out on GitHub.
Yeah.
And even before that, and I did put some code out that some pointed at this code. I did the evolutionary programming in Python. Okay, what we're focused on here is logic, right? Is deterministic logic or type logic, but you can also use evolutionary programming with these matrices once you get into the mathematical format. I did a lot of that around 2008 to 2011, but then I stopped, then I kind of moved over to this part to figure this part out, right? So when these integrate into the AIM, we will definitely have the structured logic piece, the type logic piece, and then the evolutionary programming piece, which I've got all that, I've got all those code libraries out on GitHub. They're not integrated yet.
Yeah.
All right. So, any burning features people really think should be available?
I think back on your first page that has the 7 or 8 boxes.
Oh, this one?
Yeah.
Right here.
Should have an option for a pre-structuring assessment.
Okay, so
or voting, because
a pre-structuring assessment between amend ideas and structure ideas.
Yeah.
Okay.
And to either vote on what you think is the most important idea or some other criteria, and that is related to or contrasting the structuring relationship, because then it gives you a way to measure what was learned by going through the dialogue about structuring.
Okay.
You can, for example, the thing that Christakis traditionally did was we would compare, like if he was doing a problematique where the nodes are problems and the relationship is aggravates. So does A aggravate B, and so forth. And so before they do the structuring, they'd ask, what do you think is the most important problem? And then after they're done the structuring, they say, well, the majority of you, say 60% of you, thought that this problem was the most important, but through a series of 70, it's usually like 70, 80 pairwise questions where we asked for a strong majority or unanimity of opinion, you all decided that this is the deepest driver.
Okay.
And so it's a good way to measure the organizational learning, and it's a way to something that sets this methodology apart, is being able to measure learning at a group level. There's not many facilitation methods that have hard metrics on how to do that.
Well, so Kevin, can I ask you to work with us over email to kind of define this step a little bit more, and then I'll take that and get it up on the GitHub and maybe refine the processes on GitHub a little bit? And that would be great.
Yeah. If I can learn how to get on GitHub, it's been a while, but that's where you'll talk about the idea in a dialogue on GitHub. It's like
and GitLab
comments and replies.
Yeah. So maybe what we'll do is we'll do an email or two that kind of talks about the idea. Then we can do individual session together and
Yeah.
and show you how the GitLab thing works.
Okay. Yeah.
Okay, great. That's perfect. Perfect. So I'll be sending out something to figure out what a good time is to do that.
Okay.
All righty. Well, it's probably, as you can tell, what we're doing now is we're focusing on very specific activities. One, we've done an exploration of the total space, where we're doing an exploration of total space, doing the logical groups, and now we're doing the identifying controlling parameters. And so the scope itself is a controlling parameter because it determines the type of question you're going to be able to ask. And it determines the type of question you're going to be able to ask because essentially that particular part then will be, it depends whether or not you can use the logic. With a global scope, you can use logic for inference. And with the local scope, you can't use logic. You just have to ask the individuals, the empirical questions, and then keep track of them. Later on, we'll be using some other techniques associated with evolutionary programming and other parts that the software will kind of manage in the background, and kind of forward-looking depending upon the state of the information that you have right now. But that's further down the road, just kind of a little idea about where the vision this is going. And we have about 3 minutes left, so is there any other questions, ideas, comments?
This is looking really good, and Michael and I would like to help with the next iteration. You asked about if we could.
Oh, yeah, on the paper, on the applied? Yeah, okay, good. We'll send you that. And it's, we'll do that. It's got to be smoothed out quite a bit before it's ready for anybody except Mary to look at.
Okay.
But
okay.
We'll get there in the next week or so and then get it down to you because we want to get that out a little bit ahead of time before May. Appreciate that. That's great.
Okay.
Good. All right. Well, making some real progress. And I'll get the notes out.
I wanted very briefly to say how good it is to hear, Janet, that you are feeling clearly a whole lot better than you were last time.
Oh, thank you. Thank you.
Yeah.
All right.
Best wishes to Kevin.
Yes, and I'm working on that.
Yeah, good. Thank you all.
So what about the April 20th? We have something for that, Kevin?
Yeah, we can continue working. We actually haven't entered the playbook too much. I've started on it a few presentations, and we got into some interesting discussions. So there's plenty of material. All
right, so Kevin will continue with the playbook on the 20th. Great, sounds good.
Okay. Thank you, Joe and Mary and Janet. Bye-bye.
Yep, see you later. Take care.
Bye-bye. Thanks.